In the last part of this chapter, we will talk about graphs. Experimenters vary a quantity and the independent variable and measure another quantity, the dependent variable. And the easy way to visualize all these tables and everything and all the data that you might get is in terms of graphs. So in terms of graphs, the independent variable is generally always plotted on the x-axis, which is the horizontal axis that you see here, and the dependent variable is plotted on the y-axis, which is this axis that you see where my arrow is pointing. So make sure that you label the axis whenever you are talking about a graph. For example, if you were to plot the position of any object in terms of the time, you will plot it in terms of x and y axis, plot the time, which is the independent variable, on the x-axis, and plot the position, which is in terms of meters, on the y-axis. So here's a really good example of plotting data. So for example, a nurse records a value shown in the table for a patient's temperature. First, plot a graph of temperature versus time, and then from that graph, determine the patient's temperature at noon, the slope of the graph, and if you would expect the graph to follow the same trend over the next 12 hours. Okay, so first of all, this is what the graph over time of the patient's temperature will look like. And now we're going to try to find answers to the questions that we were asked. Find the patient's temperature at noon. Noon means 12 o'clock. So the red line, starting from the hours, goes up and across. And so we can approximately say that the patient's temperature is 101.8. Okay? The next question asks the slope of the graph. Well, the slope of the graph is always the rise over the run. In this case, what we are going to use is temperature 1 minus the temperature 2 divided by the time in hours, the difference. So if you were to take any two numbers, 101.8 minus 100 divided by 12 hours minus 10 hours, that will give you about 0.9 degrees Fahrenheit per hour. Question 3 asks if you expect this graph to follow the same trend over 12 hours, and the answer is no, because this is a temperature versus time graph of a patient. So you cannot extrapolate it for anything further except for the data that you have right now. Now this brings us to the end of chapter 1. Please make sure to do all the homeworks and the example problems from the chapter. Thank you.